You were made in a star. Now, what do I mean by that? Some of you are like, wait a second. Look, I came from my mom. I'm quite sure of that, right? What are you made of? Tell me some elements that you were made of. Go ahead. Carbon, oxygen, calcium. Guys, there's something about that those elements have in common. Okay, carbon, oxygen, the calcium in your teeth. They can only be created inside of a star. That's the only way in nature they are created. That's it. Now, some of you are totally lost right now. Like, what are you talking about? Here's what I mean. Many, many billions of years ago, you have a star creating elements. Now, how do stars create new elements? What are they doing? Go ahead. Very good. In their core, they have fusion. It's so hot that they fuse elements together. They start with hydrogen, they fuse hydrogen to make helium. They fuse helium to make carbon, they fuse carbon to make oxygen, and so forth. That's how elements are made and have been made for billions of years. So what happened? Now, if a star is making all those elements, how might those elements from billions and billions of years ago have gotten out? How did they get out into the broader universe? Go ahead. Sure. Stars explode. The most massive stars explode in a supernova, and they send out those elements that they've been creating into the universe. So, for billions and billions of years, stars were blowing up, creating new elements, and after many billions of years, one day, a new star forms from that same material. Enough material clumps together to form a star, and as that star is forming, it has a little bit of leftover debris. That debris is in a disk around it, and gravity, which draws things together, gravity clumps that disk together. One clump, two clumps. The third clump became kind of important to us. The Earth. And what did the Earth form from? From the same elements that had been created in stars for billions of years before. That's what the Earth formed from. And life got started on the Earth. We don't know how that happened. There are a couple different ideas on how life actually began, but you know what life is made of? Carbon and oxygen and all of those things, right? That's what you have in common with a tree and a squid. Okay? You're all made of those same elements, and where were those elements created? In stars from billions of years ago. I want you to think about that today, and then we know the story from there. We know how life evolved. We know the story from there to get to us. But think about what you're made of today. At some point today, just think about that. Think about your body. That means that the actual things, the actual atoms that make up your body were created inside of a star. Now, I don't know which is more trippy, that or the other fact. Somebody mentioned this a few minutes ago. There's one element, and it's in your body, that stars cannot create. What element is that? Nope. Hydrogen. Hydrogen's the building block. Hydrogen is what stars begin with. So where did hydrogen get? Do you have any hydrogen in your body? What is most of your body?
Water.
Water, H2O. You have lots of hydrogen in your body. So guess where that came from? The Big Bang itself. Yeah. Guys, your body, part of your body is almost 14 billion years old. The hydrogen in your body has been around since the beginning of time. Think about that today. Just think about that when you're drinking some water today. That you're drinking hydrogen atoms that come from the beginning of the universe. It's mind-blowing. It's crazy. I mean, those other elements in your body, they're also billions of years old. Yeah, calcium in your teeth, that's billions of years old. Your body is billions of years old. I felt like that this morning, actually. But anyway. Let's do one more. One more really big concept. The universe is vast. Boy, there's the understatement of the year. I'm going to fail miserably in the next few minutes. I'm going to do my best, but I'm just letting you know I'm going to fail. I'm going to try to explain to you how vast the universe is. Let's start with something simple. Somebody tell me, how far do you live from the school? How far do you live from Stoneman Douglas? Just give me a rough ballpark idea. Somebody raise your hand and tell me. How far you live? Okay. Quarter of a mile? So funny. People from South Florida answer in time often instead of distance because we know it takes a long time to get places. Just distance-wise.
Half a mile?
Half a mile, quarter mile. I had somebody last hour 6 miles. You know what nobody has answered yet today? Nobody, when I say, how far do you live from the school? Not one person has answered in centimeters.
Wow, really?
Yeah. Because that would be weird. How far do you live? Oh, I live 3 million centimeters from the school. Why would you not answer in centimeters? It's too many. It's too small. Why would you measure such a large distance with such a tiny unit of measurement, right? Well, guess what? In space, space is so vast that using kilometers or miles gets pretty ridiculous pretty fast. You know what I mean? It's like using centimeters. It doesn't make any sense. So, let's see if you remember this possibly from middle school, 9th grade earth science or something. Within our solar system, there's a unit we use instead of kilometers. When we talk about the distance between planets or from the sun to a planet, do you remember that unit? Go ahead. Very good. An AU, an astronomical unit. And what does that represent? Do you remember sort of the definition? We know what it stands for. Go ahead. Getting to that, save that thought. Just for an AU, what distance is that? Anybody remember?
Is this with a 6?
No, I don't need a number. I just need to know physically what does it represent, an AU. Go ahead.
Distance from the sun to the earth.
There you go, the distance from the sun to the earth. Which, if you want to make a note of this, that's about 93 million miles. About 93 million miles. That's a heck of a meter stick. A 93 million mile long meter stick. That's what that is. So for example, I could ask you the distance to Saturn and you could answer in billions of miles, or you can simply say it's about 10 AUs away. Neptune is about 30 AUs from the sun. You got it? It's a more convenient unit. It makes more sense in the solar system to use AUs, but guess what? An AU is not nearly big enough when we start talking about distances to other stars and other galaxies. What do we use for that? Light years. This is important. You need to have this definition in your notes. A light year, get this exact definition, get it right. A light year is the distance, because you think year, you think time, but light year is the distance light travels in a year. The distance light travels in a year. Now, to know how far light goes, you need to have some clue as to how fast light is. Light can travel around the entire Earth, about 24,000 miles, in a second. In 1 second, in the snap of a finger. Oh wait, no, I'm sorry. It can travel 7.5 times around the Earth in 1 second. That is mind-boggling in itself. That's how fast light is. In 1 second. Now, how does this apply to space? If light is that fast, which is hard to imagine, let's find out how long it takes to get to different places. First, I have a little quote here from our man Neil deGrasse Tyson. This kind of refers to that fact that we're made of star stuff, as Carl Sagan might have put it. Not only are we in the universe is in us. Something to think about. Now, how long does it take light to travel, for example, from the Earth to the Moon? In the late 60s and early 70s, we built the most powerful rocket ever made, called the Saturn V. The most powerful rocket ever made to this day. And it took the astronauts about 3.5, 4 days to get to the Moon. Neil and Buzz launched on July 16, 1969, and they stepped out on July 20th. What were you saying? Do you have a question?
I think it's
They were all using the Saturn V. Yeah, that might have been the first time they did it. I don't remember which ones. Yep, Saturn V rocket. 4 days. Most powerful rocket ever built to get to the moon. How long does it take a beam of light, or for example, a radio signal traveling at the speed of light? About 1 second. About 1 second. This one you may know. How about a beam of light from the sun to the earth? Now that's 93 million miles. That's 1 AU. How long would it take light to travel 1 AU?
6 seconds.
Ooh, some people knew it. Just over 8 minutes. If we want to send a satellite to orbit the sun, I would guess it would take a couple months to get there. A couple months to get to the sun. And a beam of light can get from the sun to the earth in just over 8 minutes. Well, let's keep going. Let's say that we sent a radio signal to Mars, which we do all the time. We have to communicate with the Mars Curiosity rover, for example. And we send a signal to that. It takes us something like 20-25 minutes to get there. That's kind of difficult to deal with. And then you're going to have to wait another 20-25 minutes to get a response. That makes for a poor conversation. Okay, we're going to have to deal with that. We have people living on Mars someday. That's an issue to deal with. And it's the same thing with the rovers that are there. How about this? What if we go beyond Mars? What about to Pluto? Let me give you an idea of how far away Pluto is. The only time we have ever launched a spacecraft to specifically go to Pluto was in January of 2006. We launched a ship called New Horizons. New Horizons. New Horizons. Let me ask you this question. How long do you think it took to get to Pluto? It's not there yet. It's all in January of 2006. There's a big current event for my classes, and I'm still waiting on it. Next summer, by the way, July of 2015, I believe. Oh, by the way, it's not even landing on Pluto. It's just flying by and taking some pictures. I hope they remember to take the lens cover off. But anyway, that's a long time to wait. 9 years. And just FYI, it's the fastest moving man-made object in human history. And it took it 9 years to get there. Not only did they launch it with a powerful rocket, they actually swung by Jupiter and used what's called a gravity assist to pick up speed. And at that point, it became the fastest moving man-made object in human history. And it's still taking it 9 years to get there. How about a radio signal or a beam of light? 5 hours. An afternoon. An afternoon. So it takes us 9 years to get there. That's right. That's exactly right. Radio signals, microwaves, X-rays, they all travel at the speed of light. Ooh, how about this one? Let's go beyond our solar system. How about Alpha Centauri? Does anybody know what Alpha Centauri is, first of all? Go ahead. Nope. Good guess, though. You're on the right track, sort of. Closest star. It's the closest star to our solar system. It's our next door neighbor. It's our next door neighbor star. So how long does it take light, let's say, from Alpha Centauri to get to us? Light, this is our next door neighbor, traveling at over 700 million miles per hour. A beam of light which can travel around the entire Earth 7.5 times in 1 second. How long does it take to get from there to here? Over 4 years. That is unimaginable. Ballpark, I'd say that's about 25 trillion miles. By the way, if you want to take the space shuttle there, we need to look up the exact number on this. If you want to take the space shuttle there, it is something in the ballpark of like 30,000 years. I'm not kidding you. Like 30,000 years, our best technology to get to our next door neighbor. It's depressing, really. It's kind of embarrassing. The state of our technology, we think we're so advanced in everything, and that's where we're at. We're not even close to visiting our next door neighbor star. It's unimaginable. And that's our next door neighbor. Now, let me show you a picture here. Let me show you a picture of something. That's Devil's Tower out west here in the U.S. What are we looking at in the sky in this picture? Ah, the Milky Way. Now, what is the Milky Way? It's our galaxy. It's the name of our galaxy. Now, when you see it in the sky, of course you're not seeing the whole galaxy because we live inside of it. So what you're really seeing, if you're somewhere really super dark and you get to see the Milky Way, you're really, what I like to say is you're looking downtown. You're looking at where most of the stars are at. Okay, you're looking downtown and you're just seeing part of our galaxy. It's the city that we live in. It's like a city of stars that we live in. So how long does it take light, let's say, to get from the center of our galaxy to us, or for a beam of light? If we send a laser to the center of our own galaxy, a laser beam, okay, the speed of light, 700 million miles an hour, how long does it take to get from us to the center of the galaxy? About 26,000 years. That's not a spaceship. I'm not talking about a spaceship. I'm talking about a beam of light traveling faster than we can almost imagine, and it would take a beam of light 26,000 years to get to the center of our own galaxy, of our own city. I don't even want to know how long it would take the space shuttle to get there. Probably millions of years. But that's our galaxy. What about other galaxies? We have a neighbor galaxy called Andromeda. You know how long it takes light to get from Andromeda to us? Just over 2 million years. 2 million years. When early humans were still just developing, the early hominids were developing, the first humans were around, that's when light left there to get to us. And that is a nearby galaxy. That's our next door neighbor galaxy. The Hubble telescope looks at galaxies that are billions of light years away. It took the light billions of years to get to us. The entire universe, we think it would take a beam of light at this point in time, maybe 100 billion years. 100 billion years to cross the whole universe. By the way, that's much longer than the universe has existed. That actually gets pretty trippy. I don't want to get into that. But anyway, that's why we can't see even the whole universe at this point. But anyway, it's insane, isn't it? It's crazy. It's mind-boggling. If you think that you understand the scope and the size and the vastness of the universe, you are delusional, my friend. Because you can't. I don't know if we can. I don't know if we can. I don't know if we have the ability, the human brain can even possibly comprehend the vastness of the universe.